This video is going to help you with some of the signs and what they mean for the math calculations with lenses. To begin with, let's start with a converging lens. That's a lens that's fat in the middle. So for a converging lens, the distance between the object, that is the source of light, and the lens is measured from the center of the lens because we're using a thin lens approximation, and that's the variable s. The image, its distance is s prime, and it's also measured from the same center line. The lens equation is 1 over f is equal to 1 over s plus 1 over s prime. In other words, 1 over the focus is equal to 1 over the distance between the object and the lens plus 1 over the distance between the image and the lens. Now this is called a positive lens because in the formula the focus is positive. If I had a diverging lens, that's one that's thinner in the middle than on the edges, then my lens equation would still be the same, but it's also called a negative lens because I would have a negative focus in my formula. Alright, let's look at some of the sign implications. To begin with, our objects have a positive f. By our sign convention, if the object were to be on the other side of the lens, other than the light source that is, it would be a negative s. Now the image is a positive f if it appears where the light belongs. So in this video, I've got the light source on the left hitting the lens, and light goes through the lens to the right side. So if the image appears on the right side, it would be a positive s prime distance, because that's where the light belongs. If the image were to appear on the same side as the light source, that would be a negative s prime. If an image appears where the light belongs, which in this case is a positive s, or on the real side, then it's called a real image. So then real meaning that's where the light would be in a normal piece of glass, for example. It goes from left to right in my video. If the image appears on the same side as the light source, that's a virtual image. So there's our lens equation again. The magnification can tell us some things too. So the magnification is equal to h prime over h equals negative s prime over s. In other words, the image height divided by the object height, and that's equal to the negative of the image distance divided by the object distance. Notice that when you're talking about these fractions, the image variables are always in the numerator. Now this can tell us some stuff because it's a real image if I get a negative magnification. It's a virtual image if I get a positive magnification. And if the magnification is greater than 1, it's an enlarged image. That has another little tidbit of information associated with it. So in a word problem, it might tell you that you're looking at an image that's enlarged from the original. That tells you you have a converging lens because only converging lenses can enlarge. So that'll help you with the sign in the lens equation, just by that little piece of information that you have an enlarged image. If the magnification is less than 1, you have a reduced image. And the center and the radius are the same thing. It's a spherical lens. And the radius is equal to twice the focus. Or you can look at it as half the radius is equal to the focus. Either way.